Math 1332, Chapter 7, Consumer Mathematics, Section 3, Simple Interest, Video 6, Finding Principal, Rate, or Time. Consider the simple interest formula I equals P times R times T. Up until now, we've used this formula to calculate interest, meaning that we knew the principal, we knew the rate, and we knew the term. And when we put those three values in and multiplied them, we got the simple interest. However, this formula has four variables. As such, it stands to reason that if we know the values of any three of these variables, we might be able to solve for the unknown fourth variable. That's actually a pretty standard algebra thing, that if you know the values of all but one variable in a formula, you can probably find the value of the missing one. Not always. There are some formulas and equations that are so convoluted, it is difficult, if not impossible, to solve for the missing variable. But in equations of this caliber, it's not only possible, but it's very straightforward. For example, quit looking at all that. If we know the interest, principal, and rate, can we calculate the term? In other words, if we know this, and it's kind of a tight squeeze in there, that, can we figure out the term? Well, that's no good. All right, I spaced them out a little bit more. If we know the interest, the principal, and the rate, can we find the term? Spoiler alert, we can. Stop that. If we know the interest, principal, and term, in other words, if we don't know the rate, so let's move this over here. If we know those three things, can we find the rate? And the answer is, of course we can. Or, third and final version, if we know the interest rate, if we know the interest, the rate, and the term, so let's move this highlighting over. Can we calculate the principal? And the answer, of course, is yes, yes, and yes. Even better, all three of these scenarios work pretty much the exact same way. So once you know how to do one of them, you pretty much know how to do all of them. By the way, there's a fourth scenario. What if we know the principal, the rate, and the time? Can we find the interest? Of course, that's what we've done prior to this video. All right, so we're going to take a look at three problems and go through them fairly quickly because they all work the same way. A beauty salon is replacing one of its workstations. The interest on a loan secured was $93.50. The money was borrowed at 5.5% simple interest for 2 years. Find the principal. Normally, I would go through and highlight everything and say, what is this, what is this, what is this? But everything in here is fairly defined fairly straightforward. So let's just get right to it. The interest was $93.50. So this is what we were given. By the way, a lot of math problems can be boiled down to what have I given you and what do I want from you? We were given that the interest was $93.50. We were also given a rate of 5.5%. Let's go ahead and make it a decimal, 0.055. And the term was 2 years. And we're being asked to find what point blank says, find the principal. The problem-solving strategy for doing something like this is to grab an equation that involves all the things you know, the thing that you don't know. Obviously, that equation is going to be I equals PRT. But let's substitute everything we know. The interest is $93.50. We don't know the principal, so I'm going to leave that alone. We do know the interest rate at 0.055. And we do know the term, it's 2. Now, in all the variations of this theme that aren't just calculate the interest, we will know 2 of the 3 letters in the multiplication problem on the right side of the equal sign. Our goal is to figure out the letter that we don't know. In other words, our goal is to isolate, in this case, the P. Well, it's real easy to do. All you have to do is multiply the numbers that you do know into a single number. In fact, why don't we go ahead and do that first? Leave the 93.50 alone. The p is still sitting there waiting to be solved. If we double that, we're going to get 0.110. You can multiply it if you don't believe me. But if we do that, and our p is still sitting there, then we're just one move away from figuring out what p equals, because we've run across this before. To isolate a letter that has something multiplied to it, we just have to divide both sides. So let's divide both sides by the number that is preventing the p from being by itself, 0.110. That gives us enough ammunition to cancel out that, and it's going to leave the p by itself. So we get p equals whatever the answer to this division problem is, $93.50. Let's try it again. $93.50 divided by 0.110 is exactly 850. I'm sure this problem was set up to have a nice, clean answer like that. So put in all the numbers you know. To find the one you don't know, multiply the two numbers with it that you do know to get a single number, divide it away from both sides, and you'll have the unknown value solved for. I invite you to pause the video and try this one. Of course, you can always pause and try without me asking you to. I'm going to move forward with it. A broker invested, well, let's see what we're given. A broker invested $15,250. That's our principal. That's how much he started with. For 5 years, there's our term. And received $4,575 in simple interest. There's I, $4,575. And guess what we're being asked to find? I don't even have to read the problem to know. It's the only letter we don't have a value for. We're probably being asked to find the rate, and we are. I don't know why I circled the one number and not the rest. I'm inconsistent consistently. All right, well, same song and dance. We need an equation that ties together all four variables. Of course, that equation is I equals P times R times T. Our interest is $4,575. Our principal is $15,250 times the interest rate we don't know yet, times the time, which was 5 years. And now we're in the exact same situation we were before. We've got a number that we don't know that we want to find, multiplied by two numbers that we do know. Our goal is to get the R by itself. So our first move is going to be to multiply the two numbers highlighted in blue to make them a single number. 15,250 times 5 is 76,250, and that is still multiplied by R. That was supposed to be a highlight. This number is preventing us from our goal, which is to get the R by itself. Because the number in blue is multiplied, we'll get rid of it by dividing, just like we did before. Divide both sides by 76,520 to cancel the number on the R, leaving the R by itself. And then divide 4,575 divided by 76,520. And it comes out to be a pretty obnoxious decimal. Let me go through the numbers again just to make sure I did not do something incorrectly. And if I did, I'm sure you're screaming at me now. The numbers copied from the problem seem correct. The equation seems to be set up correctly. 15,250 times 5 is 76,250. That is set up correctly. 4,575 divided by 76,520. Yep, I get the exact same results as before. So it's a pretty obnoxious decimal, which I'm going to write down in just a second. But I'm kind of curious to see what was done in this particular example in terms of rounding. It's interesting because I borrowed this example from a book, changed a little bit to make it look a little different. But at no point At no point did it say anything about rounding the answer. Now, why did they get, I'm going to pause this for a second, folks. This should work. If it was 10 and 9150, then it would be You've ever made an error so silly and so casual that upon review, you just couldn't see it, and you couldn't see it, and you couldn't see it, and you couldn't see it again? And when you see it, you're like, how did I miss that? I'm pretty sure when I made the mistake, some of you watching this video probably said, you wrote something down wrong, and your answer is coming in wrong. And there is something wrong on here. It's what I call a transcription error, when you miscopy something, when you transcribe something from one line to another. And before I point it out, the reason I'm making a big deal about it is to let you know two things. Number one, it does not matter how good you are or aren't, or think you are or think you aren't at math. The best of us, regardless of whether you take one college math class or have multiple degrees in mathematics, the best of us will make casual and careless errors. The other reason I wanted to point it out is because there's a lesson to be learned from this. You will make mistakes. Math, outside of math, whatever. The worst thing you can do after making a mistake is to not benefit from it, not learn from it. Now, there's not much I can learn here that I didn't already know, which is I was careless. But what you can learn is it doesn't matter how good you think you are, you're gonna make mistakes. So did you catch a mistake I made? The mistake I made is when I divided both sides by 76,250, I have a case of what I call temporary dyslexia. It's kind of a verbal pun, but I was temporarily switching the numbers 5 and 2 here. It says 76,520 when it should say 76,250. You see how subtle and easy it is to make careless mistakes like that. Now, if you're in my class, this is the very reason why I want you to submit images of your work to me so that I can look and see if you make a little mistake like that if your answer comes out wrong. By the way, the answer to the division problem is 0.06. So as a percent, it's 6%. And at this point, that's almost inconsequential, even though that's what the question was asking. But this is the reason why you should show your work, because let's say you made this mistake on a test and you got the question wrong. if I caught the mistake that you made, like I just made there, I would probably give you full credit because you demonstrated competency in the skill being assessed, and you just made a casual mistake where you miscopied a number. Now, there may be people watching this video going, no, in a math class, if you make a mistake, you might build a bridge that'll fall. You are correct. And if I were teaching you, if this were a calculus class, I'd be a lot more about making a mistake like that. But in a class like this, where the biggest mistake that might have happened is that the interest rate might have been 5.9%, I'm not too worried about it. All right, I'll get off that soapbox, but we all make mistakes. Let's do this last problem. A recently married couple borrowed $4,500 at 8 3/4% to put in a jacuzzi, probably in the home they just bought. They had to pay $2,756.25 interest. That's a lot of interest. That's over half the amount that they borrowed. Find the term of the loan and the monthly payment. I'm going to guess that this is a long term because the interest is more than half the amount that they borrowed. And it would just take a long time for that interest to accumulate at 8 3/4% annually. All right, let's attack it. What are we given? Well, the first thing we're given is the amount they borrowed, so that's the principal, $4,500. We're given a rate of 8 3/4%. We've seen that in a previous video, so we'll go ahead and call it what it is as a decimal, 8.75%. I'm sorry, I think it was 8 1/4%. 3/4 is the same as 75%, or 0.75, if you will. So 8 3/4 is the same as 8.75 as a decimal, 0.0875. I like zeros in front of my decimals. And we're also given the interest. The interest is $2,756.25. And we're being asked to find two things: find the term and find the monthly payment. This is the first one in this video where we find a monthly payment, but you can actually find them in any such videos. All right, let's start by finding the term by using the same equation as before, I equals PRT. Our interest is $2,756.25. Our principal is $4,500. Our interest rate is 0.0875. We don't know the term, so the T is there. And just like the previous ones, we are looking for one of the three values on the right side of the equation. The two that we know can be multiplied and turned into a single value. So let's write the next line by copying the interest again, multiplying 4,500 times 0.0875 to get 393.75. That's still times T. I'm not going to bother highlighting the new number blue because I'm about to divide both sides by it. Let's make sure I write it down correctly this time. 393.75. These cancel, which gives us T equals whatever the answer to that division problem is, divided by 2. And I get a term less than a year because I typed in the division problem upside down. Oh, it's exactly 7. They took 7 years to pay off a $4,500 jacuzzi, and as a consequence, they paid almost 50. They paid more than 50% because half of 4,500 is $2,250. They paid more than half in interest because they took so long to pay it off. Well, let's find the monthly payment and see why they decided to agree to this. The future value is what they borrowed, which was the $4,500. Plus the interest, $2,756.25. And so if we add all that, we get $7,256.25. The monthly payment is that divided by the number of months. But the number of months is the term when we convert it to months. So if we do 7 years times 12, That's 84 months, 7 years to pay off a jacuzzi. That means that the monthly payment is the total that they owe, $7,256.25, divided by 84. And let's see what that is. $7,256.25 divided by 84. Oh, their monthly payment was only $86.38. So now it makes a little bit more sense. Gee, honey, I'd really like to buy this jacuzzi, but we can't afford $4,500 right now. We just got married. Tell you what, let me work up a payment plan and see what we can do. Math, math, math. Good news. I can sell you the jacuzzi. All you have to do is pay $86.38 now and $86.38 a month for the next 7 years. That's a long time, but it's only $86.38. Let's buy it. Yay. This is how people pay way much more for items than they have to. They pay it out over a long period of time to get a lower monthly payment at the expense of paying more interest. If you're okay with that, more power to you. But I don't want to hear you complaining about paying $7,256.25 for a jacuzzi that cost $4,500, and I hope it doesn't break down in the 7 years that you pay for it.